Hello, everyone. My name is Ty Traps, and today I'm going to be presenting my capstone briefing for IAE 674 Security Risk Management. And I did a risk assessment for the MetaTracker software application. So just a brief background about the application that I did the risk assessment for. The system name is called MetaTracker. It's a web app that also works on mobile devices. And basically, this application allows senior citizens who are living in residential communities to better manage their prescriptions. So they're able to better keep track of the dosages that they need to take. If they have to up a dose or lower a dose, they're able to keep track of that. They can set a schedule. They can have a timer or an alarm that lets them know when it's time to take their medication. They can learn more about side effects. And they also are able to identify any unnamed medication. So a lot of times, if someone drops a pill on the floor and they find it on the floor and they're not sure, oh, which medication is this? I guess I have to toss it. You can be able to see what pill that is. So it's kind of a all-purpose condensed application that just manages your prescriptions. And so the company that created this application is called Tetra Software. The technology stack that the team used in order to create this application is pretty extensive. So for the front end tools, we use HTML5, CSS3, JavaScript, jQuery, Sass, and Angular.js. For the backend and database tools, we use Mongo database, which is a NoSQL database, Express.js, which is a backend web framework, Node.js, which works on the server side, and JSON. And for the infrastructure tools, we used Amazon Web Services, Docker, Kubernetes, Apache, Nginx, and Bitbucket. This was the timeline that our team was working with. So the first step was to identify those risks that obviously would create a problem for the project. A lot of that was just focused on just scheduling and that sort of thing, and if there were any known blockers. Next was to analyze the risk occurrence and the probability of that risk happening, and then the impact. Next up was to create a risk control, a priority list on just things we need to tackle based on the likelihood of that happening and the impact. We drafted a plan to resolve the risk, and we're executing the risk resolution plan to be used for the remainder of the project, and we'll be able to track the progress of that project. We'll be able to further track it after the risk resolution. So this is our development team, fun group of folks. I do say so myself. So I have myself in the role of software developer. I have Christina Brown in the role of IT supervisor, and I have Jorge Menendez in the role of DevOps engineer. Now I'm going to discuss the risk assessment approach that our team took. So this slide details the scope of the analysis. So we looked at several different components when we were looking at the risk for our application. First, we were looking at physical security. So how secure is the location where the developers are working, where data is housed, where our servers are housed. Looking at environmental security. So our headquarters is located in Denver, Colorado. Probably our biggest threat is, windstorms, fire, and just adverse effects of from winter weather. So you might have some freezing, you might have maybe some power outages. So we kind of took those things into consideration. We identified the vulnerabilities, we identified the threats, and we conducted our audit and drafted a summary report. So these are the techniques that our team used in order to conduct a risk assessment. First off, we used a questionnaire. Pretty simple. We were able to get a self-assessment questionnaire from the NIST SP26, Security Self-Assessment Guide for Information Technology Systems. Secondly, we used assessment tools. Um, so the assessment, so we use several different security testing tools just to kind of review the system configurations and to identify those vulnerabilities that are in the application. And so the tools included the web app vulnerability scanner and app scan. And then we looked at vulnerability sources. So we looked at the OWASP top 10. We looked at the NIST 1 CAT vulnerability data, and then the Microsoft Security Advisory. The next technique we used was user observation. So basically, our team selected just various use cases and walked through those use cases in the application so that we could get a better feel and understanding of, just how that data flow worked, what the information architecture was like, and just kind of identifying any pain points and just noticing any kind of vulnerabilities we saw ourselves firsthand. Um, and then after that, we conducted some interviews with some of the main stakeholders in order to just validate some of the information that we did gather and have. And lastly, we did observed the actual physical infrastructure. So we conducted a site visit at the data center. Now I want to discuss the risk model that was used to determine um, the risk likelihood for each of the vulnerabilities we found. So on the first here, on the left hand column, you'll see threat likelihood with the weight factor in parentheses. So basically, it's categorized from low, medium to high, with high being worth 1.0 points in value, medium being worth 0.5, and low being worth 0.1. And so the definition of a low impact would be all of the controls are in place to either prevent or limit the vulnerability from being effective. So it's kind of a low impact to the systems and a low likelihood that this incident will be a major business disruption. For the medium definition, we define that as controls are in place that may possibly impede a successful attack from the threat, but there is also that possibility that we're not able to impede that threat. So you kind of have almost a 50-50 chance of it, either going south really quickly or quickly being mitigated. Um, and then the high definition is any controls that are in place to prevent the vulnerability from being exposed are ineffective. So this is, basically, we're under attack and we need all the resources we can to stop this threat from exposing our vulnerability. This chart kind of goes into that a little bit further, just looking again at low, medium, high, with low having a score of 10, medium having a score of 50, and high having a score of 100. So looking at low first, basically the definition would be the loss of confidentiality, integrity, or availability could have a limited effect on business operations. At the medium level, this same level of loss could have more of a serious impact on operations, assets, or individuals. And then at the highest level is loss of confidentiality, integrity, or availability could have a severe or catastrophic impact on operations, assets, or individuals. So from this chart, you can see how each risk was calculated, looking at the impact of it, low, medium, high with that 10, 50, and 100 score point. And then in the far left corner, you can see that the threat likelihood, whether it's low likelihood, medium likelihood, or high likelihood. Um, and so in using those calculations, so take the low column, for example, we determine, oh, this is a low risk, you know, is you take the score of 10 times, even if it's a high likelihood, times 1.0 equals 10. And you do the same with medium and low risk as well. And then that's how you get, kind of those lower numbers. As you see, the you have the key at the bottom where it says risk scale. So low is any number between 1 and 10. Medium would be greater than 10 to 50, and then high would be greater than 50 up to 100. Um, and so, medium impact, you have the low level of the medium impact, you get a score of 5, but then it quickly goes up to 25 and then 50. So if you have a medium impact, um, threat, but it's a low level risk, that's going to score a lot lower. And then obviously high, if you have a low risk, you get 10 points, but it's still kind of on that higher end of the low threshold, and so that quickly accelerates to 50 for medium risk, and then 100 for a high risk. High risk. About the system characterization. So now I'll discuss some of the technology components that our team used in developing this app. Um, so the application itself was developed in-house in our development workshop. We used Acquia as a SaaS platform to kind of manage a lot of the infrastructure and backend support, in addition to what our backend developers worked on. The database was Mongo database. The operating system, so we're a Mac shop, and so we use Mac OS 12 Monterey. For network support, we have Cisco routers and a firewall, and for protocols, we use SSL, used for the information transmission between the web browser and the web server. So these are the physical locations where everything was managed with the app. So the development team worked out of Denver, Colorado. The data center was headquartered, located in Denver and Colorado Springs. The help desk was at the Denver location, and the network operations center is in Casper, Wyoming. Now I want to get into more of the specifics of the application. So first, I want to look at the system users. So our main end users are the residents themselves. So these are residents that are living on senior living campuses, and they use this app to manage their prescriptions. So I explained earlier, it could be anything from managing the doses they take, if those doses increase or decrease. It could be any side effects or any kind of relevant medical information related to those prescriptions. So users are able to update their data and are also able to upload any relevant documents. The next system user would be healthcare professionals. These are end users who have so our end users, the residents themselves, have the option to share data with their medical providers. And so those providers would be able to view a list of those medications, any allergies that the patient might have, any reactions that the patient, adds to this app, so that their providers kept up to date on that. And just, you're able to kind of cross view different providers that the user might have. So it's definitely a benefit for healthcare professionals, where they can kind of see the prescriptions that their patients are using. And then lastly, you have the Tetra Tech IT support staff. And so this includes the developers who are providing that software support and maintenance for the MetaTracker system. It also includes the network support team, who are making sure that the networks are secure, and also just any IT staff who is involved with just the security configuration of the system and just making sure that data is secure. Let's take a look at some of the data that is used by the system. Since it is a medical device, you definitely have a lot of data that needs to be secured. And so you have the three biggest things that we identified is you have PII, PHI, and you have financial information. So the PII would be everything from the resident's name, their social security number, their date of birth, their phone number, address, all of that good stuff that we want to keep secure. The PHI is protected under HIPAA, and so it's their medical information that by law we have to make sure is secured and limited to people that absolutely have to deal with that data. And the PHI also includes, appointment scheduling notes that maybe residents add up to the upload to the app, or that medical providers add to the app on their end. An MRI scan, any kind of blood test results, and the prescriptions themselves. That's all considered PHI. And then the financial information. So obviously, when seniors sign up for this service, there's different tiers to kind of what they can do in the app. And so that requires them having to subscribe, and that requires a credit card. So you have your credit card number, the verification code on the back of the credit card, expiration date, the card type, just everything that's related to that financial piece that our users want to keep secure. Now we'll go into the vulnerability statement. Now we're going to discuss some of those specific vulnerabilities that our team found. The first was cross-site scripting. So basically, in that scenario, a web app can be used as a mechanism to transport an attack on an end user's browser or mobile device. And how this is done is a cyber attacker will go in and inject some type of malicious executable script into the code of the website or of the application. This could be done by sending a malicious link to a user to entice them to click on it. It can also be when an attacker stores this malicious script in the data sent from a website, search. So if you're on this application, the MetaTracker, and you're searching for, I don't know, maybe a particular prescription, or you're submitting a contact form to sign up to use the MetaTracker, you can get basically the malicious script will run in the data that's sent from that search from the user, or the data that's sent from that contact form once the user clicks the submit button. And so usually that's a typical example of cross-site scripting, is using that search form. That's basically when visitors they're sending their search query to the server, and so only they see the result. But with this code, the cyber hacker is able to also see that result. The next vulnerability is SQL injection. So basically, information from web requests, they're not validated before being used by a web application, and so with that SQL injection, what happens is SQL injection uses malicious SQL code in order to manipulate the backend database, because basically the hacker wants to access that information that we wouldn't be able to see on the front end, but that's displayed in the back end. And so that information could include any number of items. It could be sensitive, company data. It could be, again, PII or PHI. It could be user list of customers, or just any type of like private data that you don't want exposed to a hacker or anyone. And so when you're retrieving that hidden data, the hacker could go in and modify a SQL query to return additional results. So they're kind of subverting that logic, where they're able to change a query to interfere with the application's logic. Or they can use a union attack where they can retrieve data from different database tables that that they shouldn't have access to. The third vulnerability we found is the use of unnecessary services. So a lot of times you might have a web server or application server that's running just different services in the background that doesn't need to be run. For example, like Telnet or SNMP or an anonymous FTP. And so the reason why you should turn off these unnecessary services is because oftentimes hackers will take advantage of the security holes or problems that exist in these programs. And so the more services that you have running on your computer, in the background, that's the more chances, the more opportunities that they have to be able to use those services, break into them, and possibly take control of your computer. The next vulnerability we found is in the area of disaster recovery. So we found that there's not really any procedures in place to just ensure ongoing operation of the MetaTracker system in the event of a disaster or any kind of business interruption. Next, we found a lack of proper documentation. So there's a very base kind of manual just discussing, describing what the MetaTracker is used for, but it did not go into great detail about system specifications or the design or operating processes. And lastly, a huge vulnerability we found is an area of integrity checks on the data. So the system does not perform sufficient integrity checks on data that's input into the application, into the system. Um, and so just to give like a little background on that, so data integrity is basically the process of making sure that the data that you have is accurate and consistent. And this kind of goes back to integrity of the CIA triad, where you want to make sure that um, the data that you have, what you're seeing, is accurate. It is what it is. It's indeed trustworthy and it's consistent. And so you want to make sure that there's protocols in place that ensures that that data is input, that the data that users input or that developers input is free from any errors and all collected information is accurate. Um, and so there's various ways that this can be achieved, which we'll go into more during the results section. But that's a very crucial component of any system. You just got to make sure that you have that data integrity in place. Now we'll go into the threat statements. Similar to the vulnerabilities, our team identified several key threats. So the first is a hacker, right? So you have a cyber criminal. The threat actions that they would use would include the data integrity compromise, which we just discussed a few minutes ago, social engineering, just using kind of deception to gain access to the system, system intrusion and break-ins that kind of falls under that, and unauthorized system access. So breaking that authorization. And then the next would be a cyber criminal, which is similar to a hacker, but kind of takes that next step forward in that, they're not there just to kind of cause problems or disrupt the business. They want something for it. So you're gonna have your identity theft, your spoofing, again, your system intrusion, but they're usually after money. They're trying to get something from the system. So that's where that financial data from our users would be a huge vulnerability. Um, Next, you have insiders, which sometimes is not intentional, right? You may have someone who's poorly trained on the system, someone who's kind of negligent in their work. They're not very careful in what they do. But then you do also have the malicious actors. You may have workers who are disgruntled, who are just inherently dishonest, or former employees who kind of want to get back at the company. And so, they have access to that PII and PHI, so they're able to kind of retrieve that data and just use it for just criminal purposes. They may unknowingly or knowingly have inject a malicious code that spreads a virus, or any kind of system bugs. Or you just might simply have some unauthorized system access, someone who no longer works there who has access to all of this data. And then the environment, which the threat action would be natural disasters. With the location being in Colorado, you do have a lot of kind of weather concerns, just a variety of weather concerns, from wildfires to windstorms knocking out power, to just cold weather. You got freezing pipes, all kinds of things like that. This is it. This is the finale. We made it to the end, and this is the risk assessment results. So the first observation from our team is this was the cross-site scripting, the vulnerability being the cross-site scripting, the threat being hackers, um, the solution that the team originally had was doing the code review. And we looked at our calculations from our table that you probably recall from previous slides. The likelihood of this happening is medium. the impact is medium, and so we put the risk rating at medium. And so what we're recommending is, during those code reviews, making sure that there's validation of all headers, cookies, query strings, form fields, and any kind of hidden films, like all parameters. Just make sure that there's some validation there against having a specification of what should and shouldn't be allowed. So this will definitely put a great deal of work on the developers and the testers to go back and just make sure that all of that code base has that validation. The second item two, is that the observation was that data could be inappropriately extracted or modified from the database by entering through SQL injection, by entering SQL commands into input fields. And so the threat would be hackers plus criminals, that vulnerability being the SQL injection. And so the solution that they had was just having limited validation checks on inputs. The likelihood of this happening is very high. Just based on our calculations, the impact would be medium, and then the risk rating is high. So that would definitely be a big priority. And so we would have to ensure that there, again, all those parameters are in place that are validated before that data is retrieved. We talked about some of those data integrity checks. So I'm going to go a little more into it because that is such a big topic, and it is a big high priority risk that we have. So what we could do is make sure that the data is properly formatted, that it is consistent. So ideally, you should have that data stored in its original format, so no matter where it's used, you have that original accuracy that could be returned to if anything becomes compromised. After there's continual changes in different settings, as well as tracking the date and time of events, the author of any changes to the data that are in the systems. All of that should be automatically logged, and it should ideally be an automated process. And so you want to have those protocols that are in place in order to make sure that data is free from any errors. So you want to, that protocol should take into account different formats to ensure that information that's collected on paper even is just as accurate as anything that's collected digitally. And by having an input validation, having an inbuilt flagging system online, or just having a simple data review, and having those processes automated can help to just double check that data. As mentioned before, you want to have data that is properly formatted across the board, so that it is stored in its original format, as I mentioned. You want to have those accurate logging systems that just keeps track of, when data is updated or changed, who's making those changes, just really capturing, kind of doing a capture in time of just any interactions with data. And of course, you want to back up your data. So we'll kind of get to in the fourth item, but you want to make sure that data is regularly backed up. Depending on your needs, it can take place overnight, or it can happen, hourly. It can happen as frequently as you wish it to be, but it should be fairly frequent so that we make sure that that data is properly backed up. And again, this process can be fully automated, so that it is, kind of taken care of, and it allows your developers time to focus on developing. And you just want to make sure that you have those double copies of the data, and both should be in exactly the same form, so that it becomes less likely that you'll ever lose or compromise that data. And so the third item is looking at the web server and application server running unnecessary services. So the vulnerability is all, and it's the vulnerability is unnecessary services, and the threat is, it could be from almost any direction. There's no solution in place The likelihood of this happening is a medium, the impact is medium, and the risk rating is medium. So obviously those recommendations, again, reconfigure the system so that you're removing any unnecessary services running in the background that does not need to be run. Um, so that you can kind of close that loop of, bad actors taking advantage of those running services. Fourth item is a disaster recovery plan hasn't been established for this particular system. Um, the vulnerability is the disaster recovery, and the threat is the environment. And the solution um, that the company originally had was to do weekly backups only. The likelihood of this happening is medium. The impact would be high, and the risk rating is medium based on our calculations. So we're recommending to develop and test a disaster recovery plan that specifically addresses the meta tracker. What would you do if this system in of itself goes down because of some type of natural disaster or man-made disaster? And so we're definitely recommending to have the daily backups of all data and having that happen overnight. So the summary of our risk assessment is, again, just kind of repeating some of our recommendations. You want to conduct that extensive code review to just ensure validation of all headers and the cookies, query strings, and particularly form fields and hidden fields. Make sure all of that code that could easily be manipulated is validated. And the same for data queries as well, making sure that data integrity is in place. Streamline any kind of services running in the background on servers. Writing that disaster relief plan that specifically addresses support of MetaTracker. And that also includes the personnel. You want to enforce data integrity constraints and rules. Looking at entity integrity, referential integrity, and domain integrity. And lastly, you want to create that schedule for regularly updating documentation, because that, something that we saw was lacking. There wasn't enough documentation about the system. So you want to make sure that, you kind of create a schedule where that documentation is taking place regularly. Well, that is it. Thank you for making it to the end of my presentation of my capstone brief risk assessment. Um, as you might have guessed, this is actually a hypothetical application. There isn't a meta tracker yet, but the company I work for in real life, we do support kind of similar applications to help our residents. And so this was a great experience to be able to kind of look deeper into what it looks like to create a risk assessment for a software application. So I definitely want to thank you all for just listening for the last 30 plus minutes and just going through my risk assessment with me. And good luck in all of your future endeavors.